Hello everyone, this is Lord Vaskin, back for another video in basic chemistry. This one is a little bit more advanced part of basic chemistry, but it's still basic chemistry nonetheless, because today we're going to talk about valence electrons. As you can see, it's in the place where I always put my title. So, valence electrons. Now, before you get into this, I recommend you see my video on the atom, because I do mention valence electrons, and it's also good to know how the periodic table works from that video, because that video does a great job in explaining the periodic table. Because we're going to do a lot with the periodic table today. So, valence electrons. Now, valence electrons is the outermost electron shell of the atom. So, let's say if you have your nucleus right in the center, then you have an electron ring, and then you have this outermost ring. Now, this ring, let's say, is incomplete. It has missing electrons. So then, those electrons that it has present are the valence electrons. So let's say that it needs 8 valence electrons. The octet rule requires 8. And it has 4, then it needs 4 electrons. So, if it has 4 electrons, those 4 electrons are its valence electrons. Now if it gets a 5th electron, a new one comes in and joins the party, then that one becomes another valence electron, and it has 5 electrons. 5 valence electrons. So what I'm going to start off with the valence electrons is what's called orbital theory. Now with orbital theory, we have the nucleus, we have a circle for the first valence shell, and then the second one we're going to get an even bigger circle, and now I'm going to change colors to make it a little bit easier. And then we have a different type of orbital stepping into the picture. And then this is what the second layer looks like, and then the third layer will look something like this, and then we get even more fun shapes. So this is the orbital theory, what an electron field will look like, what that electron cloud looks like. This is the way that they orbit. So this is kind of confusing when it gets this big, so I'm just going to keep it small and simple right now, and say that we have these spheres. Now spheres, the way that it's easiest to think about it is you have the spheres, and spheres starts with what letter? Well, it starts with S, the S orbitals. Now you have these red orbitals here that are kind of peanut shaped. So if I draw them like this, then think of them as a peanut. Therefore we'll call them p orbitals. So we have s orbitals and we have p orbitals. And those are the only orbitals we're going to discuss today. And in the next video I will go into the other orbitals, but for right now let's just keep it to s and p orbitals. And so, time to scroll down to the periodic table. And so I'm going to move my picture of me down here. That looks good. Alright, so let's start by taking a look at the orbitals related to here. On this side of the periodic table, notice this S at the base. Now, I put that S in just to make this video in itself a little bit simpler to understand. Think about it as everything in this part of the periodic table as having an S orbital. Now, the first layer, and pretend that helium is right here. So helium also has an S orbital, and which are those spherical orbitals. So when the valence electrons start off in their new valence shell, the first 2 electrons will go into the s orbital shell. Now over here, which it's kind of hard to see because my video feed's covering it, but you have the p orbital. So all of the electrons that come in this area are p orbitals. And so what we have is, we'll start off by numbering everything down. I'm just going to put this actually over the d orbitals because we aren't dealing with d orbitals today. So let's number everything down by its period. So we have 1, 2, 3, 4, 5, 6. So with the s orbitals, hydrogen and helium only have s orbitals. They have no p orbitals because we're going to pretend that helium is over here and not over here. But it is still a noble gas. So don't get that confused, because it's a noble gas because it has a full shell. Notice that we're only filling an s shell. Notice also that the s shell is only too wide. It only takes 2 electrons. And those electrons orbit in opposite directions. And so when you have the s orbital, you have one electron going this way and another electron going this way. However, it's in 3-dimensional space. And so we have the 1s2 for helium. So helium, notice it's in the second spot. So helium has 2 electrons in its valence shell. So this is the valence shell name. This is what that orbital's name is. And it has 2 electrons in helium. So let's look at what lithium does. So notice the 2 over here. It's in the area with the s orbitals. And so we're going to say that it has the 1s2 because it has all the same electrons as helium, and then it's going to get a 2s1. 1 because it only has 1 valence electron. So this is its valence electrons because the 1s2 is a full shell. Now if we continue on to beryllium, which is the next element over from lithium, we will then get the 1 turned into a 2. Now let's move on to the p orbitals. So let's go all the way to carbon. Now with carbon, notice it's in the p section. We have the 2, so this one is a 2p. We have 1, 2p2, 2p3, 2p4, 2p5, and 2p6. And so with carbon, we're just going to add the 2p2. And then this is the valence electrons. Oh, that's a really long... Okay, so this is the valence electrons of carbon. Now, let's take a look at what a full shell looks like. So neon, this becomes a 6. Now, when this becomes a 6, you look at all of the valence electrons. 2 plus 6 equals 8. The octet rule. Now, when you look at a full shell, helium has 2. Neon has the outermost shell filled with 8. Argon has the outermost shell filled with 8. Krypton has the outermost shell filled with 8. Xenon has the outermost shell filled with 8. And radon is kind of nuclear and sometimes breaks the rules, but this is the octet rule at its finest. And this is because the s orbitals have 2, the p orbitals have 6, and so when it accomplishes that octet rule, 6 plus 2 equals 8. The s orbitals plus the p orbitals will make 8 for this beginning part of the periodic table. In fact, actually, it's true for this one too. And then the rules will get kind of different when we get lower down, but save that for the higher level videos. So I hope you stay tuned for my valence electrons part 2, which we're going to get a little bit more in depth, and I might incorporate the d orbitals. So stay with me and keep looking that good.